Hi folks, so this lesson is about specific heat capacity, which is a property of a material, and we'll talk a little bit about that a little bit later on in the video. The equation is energy equals mass times specific heat capacity times temperature change. And the good news is you get given this equation in the exam, so you don't have to learn it off by heart. So I'd like you to think about if you had two blocks of the same metal, but they had different masses. And if I wanted to increase their temperature by the same amount, which one would take more energy? And hopefully it should be quite clear that the bigger mass would take more energy to raise it by the same temperature. And likewise, we could think about if we had the same mass of a block, but that this one we wanted to raise to a bigger temperature. So we could say if it was a higher temperature, then we could say that that would also take more energy. And the specific heat capacity is a property of a material. So if I've got two different materials, they will both require different amounts of energy to raise them by the same temperature, if they're the same mass. Okay, so we could write down a definition of specific heat capacity, and that is, it is the energy needed to raise the temperature of 1 kilogram. So remember that kilograms are mass. So 1 kilogram of a material by 1 degree Celsius. So the energy needed to raise the temperature of 1 kilogram of a material by 1 degree Celsius, and that's our definition of specific heat capacity. So now we can think about how we would measure this. And so there is an experiment that you need to know about, and it's called a required practical, which means that they could ask you about it in your GCSE exam. So we would do this by getting, let's say, a block of metal, and it has two holes in it. One kind of wider hole and then one thinner hole. Okay, so this is as though I've done like a cross section, so as though I've sliced it in half so we can have a look at it. Okay, and into the wider hole we would put a heater, so an electric heater that would be attached to a power supply across here. And then into the smaller hole we would put a thermometer. So let's remember from kind of year 8, year 7, that we use a thermometer to measure the temperature change. So we have a thermometer to measure the temperature change. We have a heater which is going to supply the energy from the power pack, and we've measured the mass of our block. So we usually use a 1 kilogram block because then that makes our mass 1, which makes our calculations very straightforward. But what we need to be able to do is to measure how much heat energy comes in from here. So remembering that energy is measured in joules, what we want to actually attach here is something called a joule meter. Okay, so a joule meter. So meter being measuring, joules being energy. So it's a machine that measures the amount of energy that's going into the heater. So you'd have the power supply connected to the joule meter, connected to the heater. So all the energy that's coming to the heater gets measured by the joule meter first. Let's see what our numbers would be, what we could calculate the specific heat capacity of this material to be if we'd have done this experiment. So let's say that we raised the temperature was raised by 15 degrees Celsius. So this went up by 15 degrees Celsius. And we've already said that the mass was 1 kilogram. So we've got that here. And let's say that our joule meter gave us a lot of energy that had been supplied to the power supply. And let's say that it was 14,000 joules, which is a lot of energy. So let's look at how we could put that into this equation using everything that we've done before about doing calculations and rearranging. So we write out the equation: energy equals mass times specific heat capacity times temperature change. So I'm just going to do that. This triangle means change, and this symbol means temperature. So don't worry too much about it. It just means change in temperature. So underneath energy, I'm going to write down what our energy is, which is 14,000. Underneath the mass, I'm going to write what our mass is, which is 1. And then I know that that is times the specific heat capacity times the temperature change, which is 15. Okay, so this looks a bit complicated at the moment. So what we're going to do is we're going to simplify this side. So I've got 1 times C times 15. So I'm going to ignore the C for a minute. I've got 1 times 15. Well, hopefully we know that 1 times 15 will just be 15. So I can replace that with C times 15. And that will be 14,000. So just working our way down like we do in maths. So I want to get C on its own. So at the moment I've got C times 15. So it's times 15 that I need to get rid of on this side, which means that I need to do the opposite of times 15, which is divided by 15. And if I divide this side by 15, I must do the same to the other side. So I'm going to do 14,000 divided by 15 will give me the specific heat capacity, which if I work that out on my calculator, 14,000 divided by 15 gives me 933. Okay, and the unit that we use for specific heat capacity is joules per kilogram degree Celsius, which is quite a complicated unit that we do need to learn. So now have a go at answering some questions on specific heat capacity, please. It's quite good that you get given this equation, so it's not one that you need to remember, but you do need to remember the practical because it's something that could come up in your exam quite easily.